Good day, all of you. Today I am here with another video related to the freshwater generator and RO system only. That is your drinking water treatment part. So, in the drinking water treatment, we are going to see why it is required, why we should not drink the freshwater generator water directly, and what are the various methods. One by one, we see all these things. Why we should not consume the water directly from the freshwater generator or RO, because we are producing the water from the freshwater generator at 45 to 50 degrees centigrade, low temperature production. Why? Because we have the vacuum inside it, and we are producing the evaporating the water at 45 to 50 degree. So at this temperature, the bacteria and virus is still be alive, not being killed. Okay. So, and this is going to create a problem in your mucous membrane, disturbing your metabolism also. And another thing is that as it is evaporating and condensing, there is no salts. Calcium, magnesium salts are not there. Okay. So this also lack of the micronutrients, calcium, magnesium, and other essential elements, which is to be there in the food when you are cooking the food. That also is not possible, and sometimes may have the toxic elements also available. So we should do the treatment of water. What are the methods? Various methods. You can see here chlorination is one of the method. Silver treatment, that is your electrokatadin method. UV sterilization and ozonization. So these are the methods. Okay, I am going to show you, I am going to explain you the diagram of it with the laser pointer. Okay, so chlorine sterilization and conditioning part. So here you can see the water is coming through that, but here we have the orifice plate, because here also we have the orifice plate, and here also we have the orifice plate. So it is basically for doser A, doser B, and this is your doser C. Okay. So what happens when water is passing through this? It is passing through this metering device. These are the metering devices where you can see the water is flowing and how much. Okay. So it is going to add the water is passing through A, and here we are neutralizing it. We have the calcium and magnesium compounds, and here we have the water is going to be added to it. So neutralizing the acid absorption, CO2 like that, always being absorbed, and the hardness is there, improve the taste. All these things are happening into this doser. And after that, the water is coming out and connecting with the main stream. Here we have doser B, then again it is going like this through the metering device, and this is your chlorinated part. So here the chlorination and dechlorination is done here, chlorination is done here. Okay. So in doser B, the chlorine content sodium hypochlorite solution, or we have the calcium chloride, this granules. So water is passing through that, the chlorine is being added here, and then it is coming like that. This is your anti-siphon loop, and this loop you can see over here. And then it is coming to the filter. This is your carbon filter, basically absorbing the smell of chlorine also. And it removes the odor, and it enhances the taste also. And filtration is there always. So here we have, this is your bypass valve. We can open this one and we can close this outlet and inlet of the filter, and we can do the maintenance, carry out washing, cleaning, and with that here we have the drain arrangement. The wash water will be drained to the bilge part. So all the maintenance also can be carried out by opening this bypass. And then after that it is going through the final part, that is your dechlorination plant. Here we are doing the dechlorination of it. So again orifice is there, water is coming through the metering device and then passing out through this and mixing with the main part. So here the dechlorination, whatever is the residual chlorine content, it has to be reduced to 0.2 ppm, and then it is to be supplied for the drinking part or the potability part. The pressure tank is there, which maintains always the positive pressure, and then it is finally going to the supply. So this is complete chlorine sterilization and conditioning. This sketch you can utilize for the exam purpose, and this is going to make you understand how the complete, it is not only the chlorine sterilization, we have the neutralization, chlorination, and dechlorination, and use of carbon filter also. So it's a complete setup for the potability of water. Here you can see the same thing containing magnesium and calcium carbonate when it passes through that. So that is your dosor A. Carbon dioxide is being absorbed, remove acidity, added the hardness salt, and it gives the better taste. After that, the sterilizing agent chlorine is used, either gas or the liquid sodium hypochlorite. And in this is found if you have the liquid part, sodium hypochlorite, or the calcium chloride. These are in the form of granules through which the water has to pass. Chlorine sterilization. We are adding the chlorine to 0.2 ppm, and this is something which is dissolved in the water. If it is after the treatment kept into the domestic tank, the chlorine is doing the work and it is sterilizing the part. Okay. But in long term, what happened? It get evaporated. Then you have to further addition, extra addition from outside need to be done. The passage of water from the storage tank to the domestic system is by the way of carbon filter, which removes the chlorine taste. Okay. So the passage of water from the storage tank to the domestic system is by the carbon filter, which I told you. After that, carbon filter is the best. And then again, the dechlorination also has to be done. Advantages and limitations. Residual production. Even if it is in the tank, the chlorine is doing the work. Highly effective. Wide range of the microorganisms and bacteria are being killed. Inexpensive and easy to measure. Okay, so how much is the chlorine content? We can easily measure. It's not big deal and not much technicality is also required. So it is easily detectable, and further addition required, then we can do it. Taste and odor. Yes. This high chlorine level give you a specific taste of chlorine. So it has to pass through the charcoal filters so that it can be absorbed, and then it is used for the galley purpose or drinking purpose. So this is taste and odor is there. Ineffective against certain cysts. So certain type of the microorganism which is forming the cysts and all. So this chlorine is ineffective. Over-chlorination is also going to give you the corrosion part. So this is also the thing which is there. So that also you have to understand. Now next process, that is your electro-KAYTADIN process. So Ag plus ion addition is called Katadin effect. And this Ag plus, that is your silver ion, is highly effective in killing the microorganisms and bacteria, even in the small amount. Electro-KAYTADIN system is adding the silver ions to the water. Okay, so now I will show you again regarding the silver treatment method. So here it's a principle which is being shown over here. So we have the silver anode and we have the cathodes. So we have to supply the direct current. You can see that the current is being supplied, and the Ag plus ions are being coming out. Here you have the inlet of the water flow. Water is coming in, mixing with the Ag ions, and then coming out from the test. So electro-KAYTADIN process, basically addition of the silver ions. You can see here the block representation of the diagram. The evaporator water which is being produced is passing through the electro-KAYTADIN unit 1 and 2. One is being in use, another is standby, like that. And then after that it is going to pass through the hardening plant, neutralizing plant and all, which basically adds the minerals, adds the odor and all, adds the taste and all. Taste enhancement is also there, and filtration is also. And after that, the sterilized and the mineralized water is being supplied to the storage tank or for the domestic purpose. You can use it. Okay. Here the explanation of this, the chlorination which we have done earlier. So the problem is that the gases can evaporate and the water is not being sterilized during the storage part. But when we add the silver ions, they remain suspended in the water and do their work. Silver is toxic in the various risking organisms, and unlike the gaseous chlorine, it will not be evaporated and suspended in the water and continue doing the work, killing the microorganisms. Okay, so Is the amount of metal released to the water harm. This is something which is your how much silver ions will be released. So that is controlled by the current. Okay. So large volume has been treated, only part is being bypassed. If the large volume controlling of the amount of the silver ions is done by the current, how much current we supply, more amount of the silver ions will be produced. Okay. So in this one, we have the large volume of water to be treated. Then what happens? It has to be bypassed some amount of water and passed through the electrokatadin treatment plant, and then this bypassed water, large amount of the Ag plus ions is being introduced, and this water is to be introduced to the mainstream, and this mainstream water is going to be used as a treated water. But when with the low water flow, when we have low water flow, then what happen? All amount of the water is passing through the device and getting the ppm. So 0.1 ppm silver concentration is more than enough. Maximum 0.08 also is accepted. Here also you can see the electrokatadin method of sterilization. I have already explained. So this sketch you can utilize for the examination purpose. Here you can see this is the silver anode, which gives you the silver ion supply, electric current. Amount of the electric current is going to control the amount of the Ag ion. Okay. So if the large amount of current, large Ag ion will be produced. And water inlet is there, it is going to pass through this. And after that, the water outlet is there. So the sterilized water is coming out. So here I am going to show you about the UV sterilizer. This is widely used on board ship. Most of the ships, the domestic water which is being supplied has to pass through this, because there is no addition of your silver, no addition of your chlorine. So nothing is being added. So the operating cost of addition of all these things are not there. We are just passing the water through the UV way. Okay. So this is your water inlet and this is your water outlet. Connections can be made. Here we have the quad sleeve, inside which the UV lamp is there and giving the UV light and killing the microorganisms and bacteria. Basically breaking the membrane cell and killing the DNA so that the microorganisms will die and they cannot multiply. Okay. Here this is the holder, you can see quad sleeve holder, and here the retaining nut will be there outside also, and this all electrical supply which is going to supply the current to the UV lamp, and the UV lamp is going to lit. This quad sleeve and then the UV lamp is also going to be cleaned because after some time of use, some scale coating will be on top of it. So manual cleaning is also required. So which we have done on board ship so many times for the better intensity of the light. If the intensity of light decreases, then the microorganisms which is in the water is not going to be killed completely. So we have to maintain the intensity, and we have the alarm unit also. If the intensity of light decreases, the alarm will also come. So that also is the part. Okay. This is also the diagram for your better understanding. How does it work? I have already explained. So I'm not going to explain further over here. Just go through the explanation of it. UV energy wavelength 240 to 80 nanometer is there present in the sunlight also. And if you keep the water in the glass bottle, transparent glass bottle, not the dark colored one, and from morning to evening in the sunlight, and then you drink that water, the microorganisms and the bacteria will be killed. So this is also the process. Same we are using with the UV lamp. Okay, so this also the UV light, bacteria, virus, molds, everything, no one can survive. So that is the best thing. UV is regarded as the best solution for the water sterilization, and UV mobile sterilizing machine is also used for the room sterilization. We have seen all these things in the corona part also. It is disinfecting the water. It is having the advantage. They are not leaving any chemical residue as chlorine and the silver part. Care must be taken to ensure that all water passes directly under the ultraviolet light. If it is like that, then in that case, the method is useful. And the water is very cloudy, then there is a problem. This is something which is frequent cleaning of the pot sleeve and the ultraviolet lamp, and the ultraviolet lamp needs to be replaced. As the intensity comes down, the rate of killing microorganism and bacteria also comes down. So that also you have to think of. Ozonization process. This is basically ozone is O3, and this is having the good disinfecting part. So in onboard ship, you can see the ozone generators are there, and basically they are creating the ozone and sending it to the part. Okay. The raw water is then passed through the venturi throat, which creates the vacuum and pulls the ozone gas into the water as the air is bubbled up through the water. And this is how it is being treated. So basically, ozone is injected into the mainstream water, and this is going to kill the microorganism and bacteria. They are oxidizing the things. Okay. But another thing is that the other metals also, which is suspended in the water, they are also getting oxidized, but it has to be filtered. So this we have already discussed. Okay. Next is your another continuation of disadvantage. Required pre-treatment and hardness reduction. So in the chlorination unit also we have seen the we have to do the it is in the process only, the hardness addition, enhancement of taste and odor, but in this one nothing is there. So we have to see that. Ozone is less soluble in water compared to chlorine, and therefore a special mixing technique is needed. Potential fire hazards and toxicity issues are also there with the ozone. That also we have to consider. Another question which is coming in your phase 2 is that why it is important to use the activated carbon filter in the water treatment. So here we have the carbon filtering which is utilized in activated carbon because it absorbs variety of chemicals. And when we talk about the activated carbon, some electropositivity is given to the carbon. It is in the form of charcoal also. It is having absorption and adsorption both. And one, it is slightly electropositive. So whatever the electronegative things which is there in the water, negatively charged contaminants, they are going to attract towards this, and they are attached to the positively charged carbon atoms, and they are going to clean the water. Okay. We will go point by point regarding the advantage of carbon filters. Number one is the reduces the health risk. Due to the porous surface as a charcoal, as you can see, I have already explained. So the reduction of heavy metals and fluorinated levels of the wastewater, if anything is there, so that can be reduced. They also add the essential nutrients to the water, such as some of the calcium, magnesium, and other things to improve the quality. Filtration is also there, and this addition is also possible, and it improves the benefit to the health. Unpleasant odor. Yes, it sucks the odor. It absorbs the odor. Like we have the vacuum cleaner, it sucks the dust, it absorbs the odor, and the water is having the good taste. The odor is also removed. And taste enhancement is also there. The activated carbon thing is there. So the water is passing through the pores of carbon filters, and dissolved impurities are also being removed. Physical debris is also being removed, and it adds some taste also. So any water which is passing through the activated carbon filter will, odor is removed and enhancement of taste is also there. So that's why we are utilizing the activated carbon filter for the post treatment of the water. Thank you all of you. I hope all of you have understood it clearly. I have tried my level best to explain you and give you the answer for the treatment of water, post treatment of water after the water production from the freshwater generator or the RO plant. What are the various methods utilized and why the carbon filter is used. So this is going to help you in the answering exam. Okay. Thank you all of you. Keep watching my YouTube channel. Thank you.